When we have a polynomial of 4 terms that we want to factor, we should look to see if there's some way of grouping them together so that factors can be taken out of each group of terms. For example, in this polynomial, if I group the first 2 terms together and group the last 2 terms together, I can factor x squared out of the first 2. And I can factor 3 out of the last 2. Now when I look at the new expression, I can factor x plus 4 out of this part and out of this part. If I factor x plus 4 out of each part, I'm left with x squared plus 3. X squared plus 3 can't be factored any further, so this is the factored form of the original polynomial. Let's look at another example. Once again, I'll group the first 2 terms together and the last 2 terms together. The first 2 terms I can factor x squared out of. And the last 2 terms I'll factor a negative 9 out of, which will give me x plus 2 in both parts. Now if I didn't recognize something that could be factored out of them originally, I could rearrange the terms if I want. At this point, the x plus 2 is common to both parts, so I can factor x plus 2 out of the first part and out of the second part. And when I do that, I'm left with x squared minus 9. The x squared minus 9 can be factored further. It's a difference of squares, x plus 3 times x minus 3. So x plus 2, x plus 3, x minus 3 is the factored form of the original polynomial. You could multiply them all out to make sure that that does equal the original polynomial. Let me give you a practice problem. Factor this by grouping. Turn off the video, or pause the video, factor it, and then come back to the video to check your answer. In this problem, once again, without rearranging, I'll just group the first 2 terms together and the last 2. I can factor x squared out of the first 2, and a negative 1 out of the last 2. I have x plus 2 in common with both parts of this expression, so I can factor x plus 2 out of each part, leaving me with x squared minus 1 as the other binomial. It's a difference of squares, so it can be factored into x plus 1, x minus 1. Let me give you another practice problem. Again, pause the video, factor, and then come back to the video to check your answer. In this problem, it's already in order. We can pair the first 2 and pair the last 2. In the first 2, I can factor y out. In the last 2, I can factor 2 out of each term. Now notice in my parentheses I have x squared minus 16 and 16 minus x squared, which are opposites of each other, which means if I factor a negative 1 out of that second parenthesis, I would then have a negative 2 times x squared minus 16. In other words, from the beginning to the third step, I could have factored negative 2 out instead of just positive 2. And that will give me something in common with the first part and the second part, the x squared minus 16. Factor that out, leaving me with y minus 2. And once again, the x squared minus 16 is the difference of squares. Factoring into x plus 4, x minus 4, times y minus 2. In each of these cases, the terms were in the correct order to group the first two terms and the last two terms, but sometimes we can't group in pairs. A problem such as this. In looking at this polynomial, I can group the first two and take x out, but I can't do anything with the last two terms to give me a common factor of x plus 4. But I may notice that these first three look like they might belong together, to where if I factor down this expression into x plus 2 times x plus 2, or rewriting it as x plus 2 quantity squared, I then at least have a start on factoring this polynomial. At the point I am now, I have a difference of perfect squares, which means I can factor into x plus 2 and x plus 2, y and y. It's a difference of squares, so I have plus and minus. And if I get rid of my parentheses, I have the factored form of the original polynomial. Let's look at a second example. Once again, it doesn't look like we can factor by grouping by pairs. So let's try to factor these three terms, or this trinomial that looks like it might belong together. In this case, again, it looks like we can factor into x plus 3, which is x plus 3 quantity squared, minus 25y squared. I have a difference of perfect squares, which means I can factor into the x plus 3 quantity squared into x plus 3 and x plus 3. 25y squared into 5y and 5y, plus and minus. And getting rid of the parentheses, we have the factored form of the original polynomial. Let me give you one for practice. Pause the video, factor this polynomial, and then come back to the video to check your answer. Once again, let's group the first three together and factor into x minus 5 and x minus 5. X minus 5 quantity squared minus 64y squared. I have a difference of perfect squares, so I can factor into x minus 5 and x minus 5. 8y and 8y. Difference of squares, so the signs are plus and minus. Getting rid of parentheses, x minus 5 plus 8y and x minus 5 minus 8y.